heaps of index laws last week, and this is the last little bit of it. We've dealt with all sorts of problems. We can do it to the power of 0. What's anything to the power of 0? 1. I thought we dealt with this. Anything to the power of 1 is?
0.
Itself. Itself. X to the power of 1 is?
X.
X to the power of 0 is?
0.
If ever I have to justify my teaching, I'm just going to bring that bit of footage up and say this is what I'm working with. You weren't saying 0. You were part of the chorus. Okay, so anything to the power of 0 is 1, anything to the power of 1 is itself. What do we do with negative powers? My advice is if you're not 100% sure, we don't call out. So if I've got x to the power of -2, for example, I can write that as 1 over x squared. So I've flipped the power and made it positive. So that's how we do with negatives. What do we do with divisions and multiplications? What happens to the powers they? If we're multiplying them, if we're dividing them, take. And powers to powers, what do we do? Multiply the powers together, correct? So, using that information, because I'm going to deal with fractional powers in a second, but let's introduce them. X to the power of a half, outside of brackets, inside of brackets squared, what does that become?
X to the 4.
X to the power of? What's a half times 2?
1.
Correct?
Yeah.
Thanks. So, we know that x to the power of a half squared equals 1. So it's almost like those operations, what do they do to each other? Cancel out. Interesting. So how do we do a square? How do we undo a square when we're rearranging? What's the opposite of a squared, eh? So we use a square root. So we know that x to the power of a half are opposite operations as we get the x there, correct? Interesting, we'll get to that. So what can you tell me, can I rewrite that as, am I allowed to rewrite that as this? What would that equal? X, correct? So what I'm really telling you is that x square root of x equals x to the power of a half. A fractional indices. Now, how would I get rid of, so how would I undo, if I had x to the power of 1 on 3, what would need to go there, undo that? 3. So what do we call putting something to the power of 3? We call it a? Cube. Yep.
Would it ever be x to the power of 1 over 2 and outside the brackets?
It does. Yeah, it does happen.
That's good 1.5.
Yeah. And it happens a lot more in senior than it will here. Okay? So that equals x to the power of 1. So what can you tell me about the cube and the 1 on 3? What are they doing? Cancelling each other out. So what's the opposite of the cube? Well, it is a? Guess what that is equal to.
Cube root.
Geez, he's good. So with our fractional indices, this number here is the one that goes in the denominator. Why don't we have a number here? What do we call that? What do you reckon that is? Starts with C. A mathematical convention. A mathematical convention, just like before. I do find mathematical conventions quite humorous myself. Like when I write this, 4x, you know something's going on. What do you know is going on? There's a multiplication. That's a mathematical convention. Just like when I write a square root, if I don't have a number there, I know it's a square root. If there's a number in front of it, that tells me it's a cube root or a 40, whatever number of root it is, correct? That can be any number. What are the numbers that we're most likely to come across? 2 and 3. Okay, you might come across cubes, but the most common fraction that we deal with is 1/2 cows. Sweet? So what do we get out of that? What are fractional indices? What's that the same as saying? Well, if it's a squared root, then yes, it's a squared. What's the bottom number tell us? The power of the root, power of the root. So we've got here a power of 2, what have we got there? Power of 3. Just humour me for 1 second. If I had this, how would this look? If I had, I've got over here. I'll leave that up in case we need it. If I've got x to the power of, give me a number. 3 over 4. What would that look like? What would that be the same as?
2, I don't know.
What's the power going to be on the root?
4.
So let's start with that. It's going to be 4. What's going to go inside? X to the power of? Very good. So what happens? What happens with the numerator? It stays with the number, correct? And the denominator gets put with the root at the front, correct? If I wanted to make an index law about that, so remember our index laws, we often have things like, running out of room, but if I have a to the power of m over n, that would equal, I'd put this, and what would go where? M would go up the front, a, we've just made an index law, well done, alright? Give yourself a pat on the back, charge through the work that we've got there on our Education Perfect. Let's keep going.